See, we are going to see what we have done so far since 1940 till 2000. Then what is the present, a future, 2050. Then what is the data science? About data scientist, a role of a data scientist, how data scientist day starts, what are the technologies to be used to become a data scientist, and what are the skill set required for data scientist when you call the person as a data scientist, right? So what are the technologies we have to use and deep dive in those technologies, whatever we decide to go. Real-time examples for data scientists and machine learning algorithms. What kind of machine learning algorithms? What is machine learning? Why do you use machine learning? Right? Who should do this course? Then what you get at the end of the course? Right? This is what we are going to have. Right. Let's see. What are we doing so far? All of us are working with data, right? When we say data, what kind of data you have dealt with or you have been dealing with? Structured data in the sense like a table, file. There will always be column, value. For every column, you will specify data type, length. This is the more of structured data. That means when you see data, you can understand the data. You can talk about the data, right? You can go inside of the data. But what are the technologies you have used to store this data, to process this data? The technologies like RDBMS, databases to store data, then maybe Java, .NET, mainframes, C, C++, Oracle. These are all different technologies. All these technologies are traditional technologies, are mainly meant for transactional data. What is the transactional data? Some of you are already aware of transactional data. When you go to bank, you deposit your money. One record will be created. That's one transaction, right? You withdraw money. That's one transaction. You give a checkbook request. That's one transaction. Do mini statement requests. That's one transaction. These are all more of transactional data. This is what we have been doing, right? So we've been processing this data. We've been storing this data. But suddenly, what happened in the market? So what is going to come up? What are the different opportunities? How do we explore on this transactional data, right? What happened because of internet, because of mobile applications, the huge amount of data has got generated on your transactional data maybe, or on your products, on your services. So whatever you have been using, the huge amount of data has got generated. That huge amount of data we simply call it as a big data. Data before big data, large amount of data. It is not a technology. It's not a database. It's just a term of big data, right? But how do we define big data? When do you call data as a big data? So what do we do in big data? So big data is a large collection of data sets. What is a data set? Data set is nothing but a file. Data set is nothing but a file which holds the data in large volume. So very complex in nature. Complex in the sense semi-structured, multi-structured, unstructured data. Can you give me one example for unstructured data? Unstructured data means the data which you cannot understand by seeing it. You require special tools and techniques to understand that. Right? Any examples? Okay, semi-structured. Right, that's right. Any blogs data, Twitter feeds, Facebook data, or your friends network data, which cannot be read by manual, right? So you require special tools and techniques to understand that. And this big data, large collection of data sets, complex in nature, multi-structured, semi-structured, unstructured, and difficult to process by using our traditional technologies. Doesn't matter whatever the technology you are in, these technologies cannot be used for big data. Require special tools and techniques to process the big data, right? But there are mainly three challenges of big data. One is storage of big data. I cannot move because online people also connected to me, so I'm not able to. So, storage of big data. The major challenge is there is a huge amount of data which you have already generated. The storage of that big data. How do we store this big data? What are the databases available? Not RDBMS. You cannot store this big data in RDBMS. Yes, we could store somehow. How to process the data? How to analyze the data? Maybe you'll be using mathematics, whatever you have been doing. Then we are going to use our technologies, big data technologies. Yes, we have analyzed the data. How to show that analysis to the user, showing data to users, results, right? There are mainly three challenges in big data: storage, analytics, and showing data to users. As a data scientist, you are going to be involved in these three areas: storage, analysis, showing data to users. Now, we got to know what is the big data, right? But how do you qualify data as a big data? What are the characteristics required to qualify data as a big data? Every data cannot be called as a big data. There are certain parameters or characteristics to qualify any data as a big data. The first characteristic is volume of the data, scale of the data. So when you have a huge, large amount of data getting generated with a very high velocity, very high velocity, in nanoseconds, huge amount of data is getting generated in different varieties, multiple formats of the data. Difficult to understand the formats, right? Then with more value, the data is giving you more value to your organization, to your product, to your service. So this data can be qualified as a big data. So this definition is given by IBM, right? So whenever you have a huge amount of data with high velocity in different varieties with more value, that data you qualify as a big data. Whenever you qualify data as a big data, so you will not be going with your traditional technologies, whatever you have been using present. No use of those technologies. So we have a different tools and techniques, different setup altogether, different world, different environment. Like in 90s, we have come from different backgrounds and entered into IT, right? So we did not know what is IT, ABCD. We started from there. So similarly, here the same thing. Big data, we don't know what is ABCD, so we are going to learn, we are going to enter into a new world, right? So what are the different technologies in big data? The different technologies are Hadoop. You must have heard about Hadoop, right? Hadoop.
Shri,
What is the meaning of Hadoop?
Srinivas,
One second. Someone has.
Srinivas,
Yeah. Yeah. Fish,
yeah.
tell me,
Actually, I have a doubt here. The
please.
data, how existing data, the how the data, the data comes. What kind of data you have? The big data you are telling about big data. So the big
Yes.
data, existing data, are from what the source where it comes from the data. I just want to know this.
Yeah. Just wait for 5 to 10 minutes, you will come to know. Okay?
Yeah,
Yeah. Okay. Thank you, Suresh. We just wanted to know where the big data is going to come from. Right?
exactly.
Any other doubts? Right. So these are the big data technology. Hadoop. Any technical meaning or any meaning of Hadoop? Anybody knows how Hadoop name has come into picture? Okay. So we'll come back to that. So we have something called Spark and Scala. These two are frameworks. Scala is a language, object and functional oriented language. So we heard a lot about object oriented languages. Now, so we have a new paradigm language, that is object and functional oriented language. Okay. So we'll discuss more on that. R language, Python language, then Kafka engine, MongoDB. These are all different technologies talk about a big data. So what we do as a data scientist or big data architect or big data analytics, right? So we do less coding. It is very important. in mainframes, in Java, you write a lot of code, right? So you must have tested a lot of code, unit testing, integration testing, right? Black box, white box, and all that stuff. But those days gone. The writing a huge amount of code is gone. A very less number of lines of code. In one line, you can do wonders here. That's a power of big data technologies. You can pick 1 petabyte of data in one command. Just by using a simple command, you can pull 1 zettabyte of data or 1 petabyte of data. We'll see that what is zettabyte, petabyte. So more analysis. You'll be having a more analytical work. They're more functional. You got to be more functional. Most of the times you'll be writing programs by click, drag, and drop. Generally, we used to sit on the system for hours together. We used to type ABCD 1 2 3 4 ABCD 1 2 3 4, and used to compile each line by line. Used to test line by line, right? So now those days again are gone. Just a click, drag, drop. This is how you prepare your program. This is how you write your commands. Of course, more talking. You all know that in software, do less, talk more, then get more mileage, right? This is what you should do. But as a data scientist, you should have a more knowledge about your technologies, about your project, about your data. Here, in our traditional applications, we talk about project. The data comes secondary, right? But here in big data, we talk about data. We don't talk about project. We don't say project. We talk about data, big data. Did you receive the data? Did you extract the data? Did you clean the data? Did you go for pre-processing of the data? Did you prepare a data model? Did you test data model? Generally what we do at present, did you test that project? Did you develop that project? Did you deploy that project? Here the technology, did you deploy model? Did you test the model? Did you test the accuracy of model? This is the technology being used, big data technologies, right? You will be responsible for what? The present scenario, you are more of testing your programs, more of developing your programs, right? Then more of moving to production, release, implementations, UAT, all that stuff, right? So now, when you come to big data technologies, you will be responsible, or most of the times you'll be working with the extraction of data. So data is sitting in different places. For example, data is in web or in mobiles, like Twitter's or Facebook or LinkedIn or any e-commerce site. This is where the data is. We should be able to pull the data, extract the data. One data scientist may be interacting with 20 to 30 multiple sources to extract data. The more number of data sources. Cleaning the data. So whenever you say unstructured data, so you have to convert that unstructured into structured format. In that process, you may be eliminating unwanted data. So cleansing of data, that is another step, another activity which you are going to do more frequently as a data scientist, as a big data architect. Preparation of data models. Have you heard of data model? What is a data model? See, the data model is a solution to the data problems. Data model is a solution to the data problems. For example, you want to purchase a book. Let's say Hadoop book or data science book. You go to Amazon, you go to Flipkart or Snapdeal. You try to browse or you click on something, you chat with somebody, or right, you do some activities. You keep browsing, you read the content, you read the number of pages, you try to see the seller, all that information. You don't buy it just like that, right? You spend couple of days, maybe couple of hours. So end of the day or end of the week, you capture all your events, then store in database, analyze that. On fine day, you start seeing the recommended products down, right? These products, these books are viewed by someone or bought by someone. So they are recommending you similar to the content what you are browsing. That's called recommendation engine, recommendation model. Who prepared that? Data scientist. We are going to prepare that. That's called recommendation model. Like this, we have a different types, varieties of models which we are going to prepare to solve different problems. Am I clear? Okay. Then execution of models. Someone already prepared model, you want to know how to run those models, how to implement those models. Understanding and analyzing graphs. Graphs in the sense graphical data. Where do you see graphical data? In travel, source, destination. You want to calculate distance. You want to calculate time. You want to calculate cost. You want to analyze sources, destinations. Let's say you are in Facebook. I want to see your friends. Right? I want to analyze your graphical data. In that case, you go for graphical data storage and graphical data analysis. So far, by using our traditional technology, we have never analyzed, never stored this graphical data, right? Understanding cloud. Anybody has any idea cloud? What is a cloud? Any cloud? Any idea? Sharing the infrastructure. Yes. Then data center, entire data center. Okay. So what data center contains? Computing engines. Infrastructure will be there, platform will be there, software will be there. Right? So, for example, you want to implement one idea. That idea requires 20 crores. You don't have 20 crores. How do you implement that idea? Why 20 crores required? To set up infrastructure, platform, software, all that stuff. But for this, the best solution is a cloud. All computation engines are put in cloud, access through internet. So IBM, Microsoft, Amazon, there are many companies are in cloud. They have already created a data centers. Data center is the place where you install all your infrastructure, platform, softwares, and provide access to them. Then use as per your requirement. Today I require 100 GB of memory. You pay only for 100 GB, use it. Pay as per usage. That's called cloud computing. So you will be using software as a service, platform as a service, infrastructure as a service. You don't own them. That's called cloud computing. That's exactly the main thing. Called cloud computing. You don't own anything, right? You rent it, or someone will own that server. Then you will have a connectivity through dummy terminals. Somewhere I have a Java software, Oracle software. I need to access from my laptop. So I'll access through my cloud, internet. I get everything. So as a data scientist, you also need to understand cloud computing, because almost all big data technologies are placed in cloud. All the companies, right? Then building the big data team. If you are a very senior person, you also know how to map big data team with your projects, right? So once you go through the entire course, you will come to know all these things. Right, so there are some of the statistics. You might have gone through this already. 2003, we used to have 500 million devices connected to 6.3 billion people. By 2020, we are going to see 50 billion devices connected to 7.6 billion people. Almost every person will be carrying 6 to 7 devices. Think about amount of data which is going to be generated. A huge amount of data. IBM estimates that, or claims that 90% of today's data is already generated in the last 2 years. Any guess how much amount of data got generated? Any guess? Of course, we know bytes, gigabytes, megabytes, terabytes, then petabytes. After that, zettabyte. After that, exabyte. After that, yottabyte. After that, brontobyte. After that, geobyte. These are the memory measurements for big data technology. But how do I understand? Before that, let me tell you, someone asked me how this big data is getting generated. You all know that in a minute what is happening over web or over mobiles and different applications, different products, different services. If you take an email, 168 million emails are being sent in a minute. Think about our day, month, year, how many mails are going to be circulated. One mail may talk about a product, one mail may talk about service, another mail may talk about solution, another mail may talk about problem, another mail may talk about ideas. If you're able to capture those emails and analyze those emails, there will be a lot of problems can be prevented or solved. You can increase your company ROI, return on investment. You can increase the profits, decrease the losses. Similarly, YouTube, Skype, there are many places where you get a big data. All these are contributing to generate a big data. All these products, tools, whatever it is. You can say plainly, terabytes, we already store, we already process it, terabyte, 2 terabytes. Some cases, some engines may be processed petabyte also. In normal traditional technology, that's a very difficult task. Very rare. More than terabytes, we talk about big data. Petabyte, exabyte, zettabyte, yottabyte, brontobyte, geobyte. But how do I understand in layman terms? If I say zettabyte, how do I understand? See, you can estimate, if I say terabyte, you can estimate that one laptop can take 1 terabyte memory. In layman terms, you can say that, or 2 terabytes. But how do I understand zettabyte? 1 zettabyte is equivalent to 1 CD to every individual across the globe. 1 zettabyte is equivalent to 1 CD to every individual across the globe. If you distribute one CD to every individual, that is equal to 1 zettabyte only. Now, already 8 zettabyte is generated. The IBM, Gartner, McKinsey, all these survey companies already estimated that 8 zettabyte is already generated. That's where the challenge is. That's where people talking about more opportunities. 20 lakhs, 30 lakhs, or 4.4 million job opportunities, whatever it is. All these guys are talking based on the data what we have got till today. The 8 zettabyte of data. That means 8 CD to every individual across the globe. By 2020, we are going to see how many zettabytes. Any idea? Any guess? Any guess? 100? Oh, it may be too high. It may happen. We don't know. If India, China is involved in more internet and more mobiles, it may happen. So now more digital world, right? It may happen. But the estimation is 40 zettabyte of data is going to be generated. It's a huge, huge amount of data. This is where our money is. Your money is. You decide where your money, how much you want. You grab it. That's it. Add big data skills and grab them. The more skills you add, more tools you add, the more salary you get. K will be increased. K will be increased. That's it. It's like that. Right? So these are some of the examples for structured, unstructured, multi-structured. Structured data like mainframe, DB2 data, SQL Server, like Sybase, Teradata, unstructured like social media chart scripts, or analytics, blogs, feeds, likes, dislikes, follows, ratings, these kind of things. Multi-structured like e-commerce data, weather reports, currency, all that stuff. We'll come to know all these things practically. You don't need to worry much about this. I just want to give you idea about them. Okay. So these are all the vendors or companies who are supplying big data technologies, big data tools. If you want to implement Hadoop, you contact these guys. If you want to implement Spark, you contact these guys. If you want to implement Scala, you contact these guys in your projects, in your models. Okay. So these are the companies where we have big data opportunities. Almost nowadays every company is having a requirement, at least some companies talking about big data. Many companies are talking about big data, right? They started now, very early. Like how IT started in India 90s. We are in that stage. Right? So IT opportunities, I say, dot. Now when you talk about big data opportunities, a big circle. Think about which one is big. IT or big data? It's a big data. We are in dot. We need to enter into big circle. It's a big data circle. That's where the more opportunities, more money is. It's industry-wise hiring. Almost all industries, everywhere you go to any retail store, there is a big data analytics. You go to any healthcare systems, big data analytics. You go to any wine shop, there are big data analytics. I'm talking about US, UK, Germany, Japan, those countries. Construction. real estate, food and service. There are many places, right? Data scientist. How data scientist day starts? How data scientist day ends? What are the different activities data scientists will do? You know, if I ask you, you're a mainframe programmer, or mainframe lead, or QA lead, or Java lead, or Java programmer, or Oracle lead, Oracle programmer, you know what you are going to do. How your day starts, how your day ends, right? But similarly, data scientist day starts data extractions from multiple sources, data cleaning, observing the data, identifying the trends in data, spotting trends in data, and preparation of data models, testing of data models, execution of data models, right? Using these technologies, data scientist technologies, Hadoop, Spark, Scala, R, Python, SAS, Liquid, Tableau, and different databases are there like MongoDB, Cassandra, HBase. Don't worry about the names. When we started IT courses, you know, the names like mainframe, Java names also are the same, right? 90s people used to call Java. In Telugu we have something called Java, right? So people used to think that some liquid is there, Java, you know, in Telugu some liquid is there. Some ragi Java, some Java they used to prepare. Just like a buttermilk. Or people used to think like that. So don't worry about the naming convention, MongoDB, Elasticsearch, like Solar, Pig, Hive, HBase, Oozy, Scoop, something like this. I will tell you what you need to learn, but these are the technologies available. As a data scientist, you are going to be involved in this technology. But what is mandatory here? Where you will stop? I will explain that. Okay, so let me tell you the overall. Let me give you overall idea of data science process. Right? So you collect raw data, then you process the data, you clean the data, explore on the data. That means analysis, analytics. Then you prepare models, that means algorithms, then communicate those algorithms, take decisions, or send that model as a product to again social or public to start using it. Let me relate this process to our example what we discussed, the recommendation engine. So whenever you are browsing your products, what are you going to do? You open a website or e-commerce site. You do different activities. You click on something, you view something, you download something, you do some activity. Collected. Your raw data is collected, then processed. They have cleaned, eliminated unwanted data, explored on it what this fellow is looking for. Looking for price, looking for quality, looking for number of products, looking for content, are interested in people what they are buying. They analyze it. Then prepare one model, recommendation model as per analysis, their analysis. Then show that model, take a decision. What? This model has to be showcased, has to be executed to so-and-so category people. You are searching for 50,000 mobile, so they will maybe showing to you, all software engineers, only those people can afford, or business people. Not to villagers, they cannot afford 50,000 mobile, they don't require also. Right? Then release the product to again back to the place where you generated raw data. See the magic of behind the screens. A lot of things are happening which we are not aware of. Okay? Who can become a data scientist? Any simple person. You don't need to have a great skills. You don't need to have a great knowledge. So many people are scared whenever you say data scientist. Scientist means, oh, it's a very difficult job. No, it's very simple. That has become simple with big data technologies. What technologies introduced here. Very important thing, you write a very simple code. Only that fellow can become a data scientist. If you want to write a 3,000, 4,000, 10,000 line of code, don't be in data scientist or big data. If you are passionate about building the code, sitting 18 hours, 20 hours, don't come to big data technologies. By using these technologies, Spark, Scala, R language, Hadoop, We'll be going through each and every individual components. Don't worry much now. For what? For storage of big data. Get in. Processing of big data. Visualizing the big data. Where? And cluster. You know server. You know client. You have been working, right? What is a cluster? Any idea? What is a cluster? Group of machines. What for? Even clients are also group of machines, right? Even there also we have storage of data. Sorry?
Load balancing actually over number of nodes are there in a cluster.
Okay, you are getting to the point, right? Node. Yeah. Anybody?
For maybe
Okay, let me tell
distributed
you.
processing of the
Cluster.
data.
What is the main use of cluster? Why we have gone for cluster? As we have been saying that we have been dealing with terabytes of data. We don't have a huge amount of data. Now the time has come to handle a huge amount of data. Whenever you talk about huge amount of data, more work, more people required. Then more parallel processing is required. So you got to process the data parallelly so that your processing will be faster. The computing is faster because you are going to deal with a huge amount of data, zettabytes and zettabytes of data. That is possible in clustering environment. The network computers, all computers put together is called a cluster where the machines are going to share the memory, share the computations, do the parallel processing. Three things are happening here in a cluster. Data is shared, computations are shared, then the processing computations also shared, parallel processing. Do the work parallelly. Every machine will generate some result. At the end of the process, all the machines results will be collected and shown as a single result to the user. Right? As a big data scientist or analytics engineer, you also require to have a basic mathematics and statistics. Standard deviation, mean, max, minimum, range, scale, these kind of things. But we don't need to derive any formulas or we don't need to derive any theorems like mathematician. We have already built-in functions in Spark, Scala, in Python. You just need to understand them and use in your programs. Alright? So all these things will be done for only decision making, business decision making. Finally, how many people are going to leave my company in 3 years? Out of 1 lakh people. Churn analysis. How many people are going to disconnect my services? Airtel wants to do that, churn analysis. Prediction. I want to predict how many customers are going to come to my business when I start this business. Predictions. Right? Did you understand now? Who can become a data scientist? Anybody can become a data scientist. You don't require a great degree, a great knowledge. You can start from here. What are the tools required? What are the technologies required? Where we talk more as a data scientist, especially in big data. The very first thing, mandatory thing is Hadoop. Without Hadoop, you cannot claim you as a data scientist or big data architect. This is going to be a base. Hadoop is what? Framework. It's a framework. I'll tell you what is the framework, don't worry now. In the next slides, we are going to see what is the framework. Spark is another framework. Fast computing. Scala, a language. Object and function oriented language. These are mandatory things. So we are going to have data science with the Spark and Scala. Your title is data scientist or data science and big data analytics with Spark Scala. in which we have Hadoop involved. If you want to get more salary, include R in your profile, include Python. But when you learn Scala, 90% of learning R and Python. Basic differences are there. Once you are master in Scala, R, Python is very easy. But there is another difference. We'll come back to the difference. I'll tell you. SAS is licensed. All other big data technologies tools are open sources. Let me tell you that. That's a major advantage to do your pilot projects, to do your POCs, to showcase any sample modules to your customer. You don't need to pay for it. If you want to build any product in Microsoft.NET, if you want to build any product in mainframes, if you want to build any product in Oracle, you need to have a license. Even to showcase, right? Even to do pilot projects. But here you don't require to pay any money. But how will they generate money? They generate in support and maintenance, not selling products. They'll ask you to use a product. Once you start using, you pay accordingly. Those days, first you purchase a product, start using it, also pay for support and maintenance. Now the things have been changed. You don't need to buy anything, you don't need to own anything. Someone already owned, you just start using as per your requirement. You want X, you grab X and start using. You don't want X, disconnect it immediately. You want Y, take Y, your payment stop there. But once you own it, you have to carry for lifetime, right? That's going to eat your money. But here you will save a lot of money. If you don't want, you disconnect anytime, you don't pay. If you want, yes I want, you start paying. That's it, your choice. You decide what you want to do. As for your business, you downsize, upsize, whatever it may be. Here, then we have a Tableau ClickView. These are visualization tools. I told you big data challenges, three things, right? Storage, process, show. Wherever you want to show, you are going to use Tableau and ClickView. But as a data scientist, you may not be involved in all the areas. Your project is very, very small. You may be involved in all three areas, but almost all projects are very big projects. You may be involved in data extractions. You may be involved in data cleaning. You may be involved in data modeling. You may be involved in training data preparation. You may be involved in preparation of algorithms, mathematical algorithms, statistical algorithms. It all depends on the project and mapping of your managers once you enter into the project or company. Right? But mandatory things are Hadoop, Spark, Scala, machine learning, which we are going to discuss. These things are required to start with. As I told you, as a data scientist, you will have to deal with multiple people, multiple components, multiple storage systems, relational, web data, files, logs, ETL systems, web. I told you 20 to 30 sources will be there to extract data, to extract big data. Right? So technically we will be discussing on this. So don't worry, we will be writing programs also to extract data from web. For example, Narendra Modi is commenting in Twitter, or many people are commenting on Narendra Modi decisions. I want to extract that and analyze and provide some analytics to public and real time, then and there. In that case, we go for online analytics. All right. Let's talk about Spark. What is a Spark? Spark is a framework. This is getting promoted by Databricks company. The founder of Spark started Databricks company. Databricks company is started in 2013. Whenever you find time, you go through databricks.com. There is a lot of investment going on, a lot of people moving to Databricks. They are mainly to promote big data technologies, support big data projects, generate new models, change the shape of big data technologies. Technology point of view, whatever Microsoft achieved in 25 years, Databricks achieved in 5 years. Not revenue point of view, technology point of view. They are more advanced. If you go through their videos, if you go through their site, you will come to know what is happening there. You will really love it. You just follow this. You will be there. Your money will come automatically, will flow. Trust me, it is true. You can decide the figure here and target the figure and get the job. Say, I want 25 lakhs. You decide, you write down in your notebook, start adding these skills, start entering interviews, you will get it. Trust me. You must have read these news also, right? Many people, even freshers, are getting 11 lakhs, 12 lakhs as starting salary in big data technologies. People are spending 8 lakhs, 9 lakhs to learn big data technology, analytics, data science. Many universities are offering. There is no course less than 2 lakhs, except in that software. We are more people oriented. So we want to build more people in big data technologies. Passionate about building the people, building resources. Right, Venukamna? Yes, right. Okay. Because he knows me. Spark is a framework. What does it mean, framework? It is built with some software libraries. What for? What is the use of this framework? You know what is the use of Java? You know what is the use of C, right? You know what is the use of DB2? You know what is the use of Oracle? Now I should know what is the use of Spark framework. The Spark is to analyze the big data, provide analytics in big data. It is not a storage engine. It is not a front end. It is not a back end. Whenever you get a project, people will keep asking, what is your front end, what is your back end? Here, this will provide you analytics. This understands data, not projects. By using a Spark framework, you build a data model. You build a solution to the data problem. The Spark is the best tool for clustering environment. Just now we talked about cluster, right? It's a distributed storage, distributed computation, also parallel processing system. Right? The Spark can be installed and configured in cluster. That means Spark is there in every machine. Spark receives the data, does the processing parallelly, generates the results faster, and show to the user. But in Spark framework, you write a program by using a language that we call as API, programming interface, application programming interface. That language may be Scala or R language or Python language, whichever you like, whichever you are comfortable. But entire Spark is built with the Scala language behind Spark. The Scala is more suitable for Spark. With Spark and Scala, you do more activities. The more energy comes into picture when compared to Python with Spark. Of course, there are some cases where Python takes a lead on Scala. There are many cases Scala takes lead on Python. But entire Hadoop or behind the Scala, there is a Java. Okay. But we don't need to learn Java here. Not required. Some people say the big data means Java. No, I'll clarify that very soon. Right? But Java concepts may be required. If you are a Java programmer, it's very easy to pick up. But doesn't mean that other people cannot pick up. So even for other people also, it's very easy. It's all are same. Just like entering in a first year BTech. Right? Okay. The Scala programming language. When I say programming language, don't think that, as I told you, you write a very big line of code, you don't need to write. Very simple. In any language, if you are writing 100 lines of code, in Scala, 2 lines. 2 lines is equal to 100 lines of code. Whatever you are achieving with 100 lines, you can achieve in 2 lines in more effective manner. That's the power of Scala. I'll show you the code also. Fine. I understood what is Spark framework. I am saying that it is for analytics, but where is the data? Data is there in Twitter. Data is there in Facebook. Data is there in e-commerce applications. I want to extract data, live data as it is coming. Go for Spark streaming module. This is one of the components of Spark. Ecosystem of Spark framework. It's a built-in. You are going to write programming in Spark streaming and extract data live. You may be thinking that I am 20 years experience, 15 years experience, I cannot sit and code. So you will be coding only 2 or 3 lines or max 100 lines, not more than that. Just like using your mobile, using your calculator, not more than that. Very simple. Go for Spark streaming. Yes, I have RDBMS data. My company has 10 RDBMS systems. Already I am generating data, existing data. I want to do some analytics on that data. Maybe transactional data, which discuss banking data, or insurance data, retail data. In that case, go for Spark SQL. Another module, Spark SQL. Then I have a graphical data, as we discussed, network related data. Go for Spark Graphics. Or I need to build data models, algorithms. We'll see what is algorithm. Machine learning. In statistics, you have a machine learning algorithm, right? Logistic regression, linear regression. Have you gone through that? I think you are mastering that. You need to teach us. Right? Navi-based algorithm, random forest, KNN, K-means clustering. Don't worry about the names. Somewhere you must have heard about these names. Not to scare you, just to get familiarized with these names. They are very simple ones. So all these are all built in Spark mlib, M library, machine learning library. So like this, Spark has multiple components for different activities. It has got multiple components. So now we have got a little idea about Spark, right? Spark is the framework. It has multiple components. There are multiple APIs, Java, Scala, Python, R language, but we will be learning Scala, right? These are all the multiple components what you are seeing here. This is called the Spark ecosystem. When you want to do analytics, you have to have all these components based on the data sources what you are getting. As a data scientist, you will be involved in all these areas, all these modules. Clear? The Spark streaming, as I told you, data may be in Twitter, data may be in HDFS. HDFS means file system of Hadoop. This is more of technical. We'll come back to this. Don't worry now. This is how code looks like. Scala code, Java code, Python code. Look at this one. Scala 1, 2, 3, 4 lines. Java 8, similar to Scala, but when compared to Scala, Java code is more. Python, Scala almost the same. The only val is the difference. Here there is a val, here there is no val. Very simple. I told you, when you learn Scala, 90% of learning Python in R language. The code is very simple. This line is to pull data from Hadoop. That's a simple line. This line is to filter some data. That's it. Filter is a method, text file is a method. Like this you will be using methods, predefined methods. We are going to learn what methods to be used there. What functions to be used there. When you install Spark on your machine, you are going to see prompt like this. This is called Spark shell. This is the place where you type commands. What I have shown you. This looks very simple, but very, very powerful. Very powerful. It can process any amount of data. Any number of lines of code can be prepared here. That we are going to see in our classes, future classes. Right, coming to the actual subject, the data science subject, heart of data scientist. Data science, what's the machine learning? Any idea? Machine learning. Machine learning. Okay. Machine learning Machine learns from where? From data. Data is the fuel of the machine here. Machine will use the data. What's a machine? Support program what you prepare, algorithm what you prepare. That's a machine. That we call it a machine. That receives the data. That data we call as the training data. And understand that, generate the solution. Learn from the data, generate solution. Let me give you one practical, very simple, basic example in layman terms. Let's say I gave you a fruit basket. It contains mangoes, bananas, grapes, known fruits. I gave you this fruit basket. Ask you to categorize them. Mangoes one side, grapes one side, bananas other side. What you do? In fraction of seconds you do it, right? How? How are you able to do it? How do you know grapes? How do you know apple? How do you know banana? How do you know? How do you know? Someone already told you, right? You already learned. You already tasted. You concluded. Picture is stored. History is stored. Historical data is stored already in your mind. Historical data, remember, we use this term more frequently in machine learning algorithms. Historical data. You predict on historical data. Take decisions on historical data. Provide insights on historical data. So here historical data is already stored in your mind. Based on that you will be able to map. Your mind will map with the grapes, apples, then you will be able to categorize them. Say these are apples, these are bananas, these are grapes. Fine. This is called supervised machine learning. In supervised machine learning, output is given, target is given. The fruits have to be categorized, apples have to be separated, grapes have to be separated. This is the target. In supervised, what I am trying to say finally, in supervised learning, targets is given, targets are given. This is called in machine learning algorithms output variables, target variables. The terminology being used. We never used in our traditional technology, right? Target variable. Have you used? Output is given, but the same fruit basket is given again. Second case, but this time I don't know, you also don't know what kind of fruits are there. But you are asked to categorize them. In this case, what you do, tell me. Very simple. In this case, what do you do? How do you categorize them? No? Based on the shape. See, the one parameter. Whenever you are given something, don't know something, you look for similarities. When you are asked for categorization, right? Similarities, maybe shape, maybe color, very good, maybe taste, maybe size, maybe weight. These are all called features. Whenever you don't know something, we have to extract features, labels, label points, parameters. Then start applying iterations. He said shape. Now I got the shape, parameter, I apply on the data. Segregate up to some extent, but that's not going to give me correct result. One iteration, I call it as one iteration. The second one, color, categorize them. Second iteration. Third one, weight. Fourth one, size. Another one, taste. Like this, I keep applying iterations, one by one, one after another. But when you come to big data technologies, a huge amount of data, more number of iterations will keep performed internally. 1,000, 10,000, lakh times multiple iterations will keep happening internally in machine learning algorithms. That's where you see the Spark actual advantage. The Spark is best suitable for iterative algorithms. That's a kind of loop. Keep running, keep running, keep running, keep running internally. From the data, from the features, That machine will learn and segregate. Finally, it says these are X fruits, these are Y fruits, these are Z fruits. You will name it. Outputs are not given. This is called unsupervised learning. Have you got my point? Wherever outputs are given, supervised learning. Wherever outputs are not given, unsupervised learning. You need to discover everything. That's called machine learning algorithms. This is what we are going to do. Finally. Clear? Okay. So now we have understood what is the big data. Fine. We have understood what is a Spark. What skill set is required to become a data scientist. Then what is a cluster? What is a distributed environment? Right? This is what we understood. What is the machine learning? What is the model? What are the data science activities? What is the data science flow? What are the data scientist tools, right? Fine. So I just want to clarify one thing here. Many of you or some of you might be having understanding that data analytics. You see many places advertising like data analytics. Then big data analytics, right? What's the difference here? Let me tell you. So this data analytics is a very old one. It's already there since 1950s. It's on numerical data, numerics, but low volume of data, not huge amount of data, not in clustering environment. But what tools to use here? More maths, more stats, more math, more stats. Maybe you are master than all of us, right? Then what other tools? R language, then SAS, then SPSS tools, and Excel. SAS, statistical analysis tool. Right? These are the tools required. This area is completely non-technical, non-clustering environment. Just a normal data, it's been there. Data analytics is there. But what is new? Big data analytics. What does it mean? Big data means numerics plus text. Before text was not there, not much text. Am I correct? When there is large volume data, people thought about cluster. People thought about distribution, computation, storage, parallel processing. Text analytics, big data analytics, text analytics. Here we'll be using little math, stats, then Hadoop. In this we have multiple components again. Spark, multiple components again. Scala, Python. Of course, you can use R again. These are completely technical. If you want to simplify your life, choose big data. If you want to complicate your life, choose about. Here there are many people, many PhD holders, many professors, many people already working in this data analytics. It's not new, but it has become more famous with the big data analytics. This is difficult to go through it. No limitations. But here there are certain limitations that you can limit with the help of these technologies. They can simplify your job. For example, if you want to prepare recommendation model, here you need to use more mathematics, more statistics. But here less mathematics, less statistics with the help of these tools. These tools will simplify your job. Already there in your machines. So what are you going to learn here? Data science and big data analytics with Spark, Scala, Python. Then machine learning in this. Here what I am going to cover, completely big data analytics life cycle, data machine learning algorithms, Hadoop, Spark, Scala language, then introduction to Python and R. Because Spark is capable of integrating with R and Python. Some cases you have more numerical data to be processed in clustering environment. R alone cannot process in clustering environment. In that case, you take a Spark support. You will integrate R with Spark. In Spark framework, R language. Am I clear? Are you clear now what are you going to learn, what you are going to become? Your resume should talk about this. There are multiple components inside this, but these are main components. This is your title. Am I clear? So sometime let me. Yeah. Yeah. R. Because more mathematics, more statistics. To implement this in R is difficult. To implement in Spark is easy. That's what I'm saying. Okay? But here R is not clustering. Here R for clustering environment. Yes, you are right. You are 100% right. They are completely automated. Okay, for some time let me talk to online people just for a couple of minutes. Where they are. Hello friends, Suresh,
Yes, Srinivas.
are you fine?
Yeah.
Vishwanath,
Yeah, the session was good.
can you
Yeah,
speak
we are
loudly or
following.
increase your volume? Hello.
The session is good. We are following you.
Oh, great. Okay. What about Kranti?
Yes, Srinivas. Yeah, it's fine. I actually
Any
have
doubts?
just one small query. It's not
Please.
basically query, just a small. I can't help notice, but I think like whatever concepts
Please
which you
speak
have
loudly.
covered. Hello, can you hear me, Srinivas now?
Yeah. Tell me.
Yeah, I can't help notice, but some kind of similarities about the concepts which you have talked about, like the cleaning of the data, extraction of the data, and then preparing the data models, doing the
Yes.
analytics. These are the kind of concepts normally we do in data warehousing, right?
Right.
So,
But not in clustering environment, no parallel processing, no
okay,
big data processing. Did you ever process the text there? Did you process videos?
okay. So that's
Did
the
you
main
process
difference.
audio?
Okay,
Okay. Did you
okay.
prepare data models, machine learning algorithms in clustering environment? No, right?
Okay,
Yeah.
yeah. Thank you.
That's where you find difference. Ramakrishna, are you fine?
Yes, sir.
Okay, great. Okay, let me give you a brief idea about Hadoop of another 5 to 10 minutes time. Okay, anybody has any idea what is the meaning behind Hadoop? No idea? Actually, there is no technical meaning. Zero. Any meaning behind elephant? Yellow elephant? Big. Okay. Well, let me tell you. Duck cutting, he invented some algorithm. That algorithm will take care of distribution of data, distribution of computation, parallel processing. He was struggling to name for that algorithm. His son was playing this toy, whatever you are seeing, elephant toy, with the same color. And he named to this toy as Hadoop. And he was saying Hadoop, Hadoop, Hadoop. Duck cutting heard that name while he was playing. Then identified that it is a unique name, easy to spell, let's name it as Hadoop. That's how the name is evolved. There is no technical meaning inside this. There is no rocket science, zero. The same thing used as a logo, the same toy. Okay? It started in 2002, duck cutting. Slowly companies started using as advantages of Hadoop. In 2009, most of the companies started using, now almost everywhere. See, Hadoop is it's not going to be our main thing as a data scientist. It's one of the components. Remember that. Okay, Hadoop is getting promoted by Apache. Apache is the foundation. This company supports all open sources, promote all open sources, provide services for all open sources. Don't ask me why, how will they get money? There are a lot of ways for revenue generations for them. Hadoop is a framework which contains software libraries. These libraries are used to distribute data, distribute computations, do parallel processing by using simple programming model. Understand that, simple programming. I am always using simple, simple, simple. I want you to prepare for that. Alright? So Hadoop is designed, this can be scaled from single machine to thousands of machines. We have only one machine to work. Yes, you install, configure Hadoop in one machine, start working. You have 10,000, yes, install, configure, start working 1,000. The scalability of Hadoop is very, very, very high. That's the reason it's so popular. Another reason is accessible, open source. Go to internet, search for it, download, that's it. Simple as that. Very simple to use. Just like using your mobile. These are the job opportunities, more than 50% unfilled. Anyway, these are some general things. Let's move on to technical things. Compared to Java, Hadoop is going with rocket speed. These are all the different roles what you are going to get after completion of this course. These are all different responsibilities. There are many, so don't worry about this. We'll be discussing each one more clearly. These are all different Hadoop components like HDFS, Hadoop Distributed File System, like a MapReduce, it's a programming engine, like a PIG, PIG PIG. You know what PIG does, right? Eats anything, unlimited quantity. Similarly, here this PIG can take any type of data, unstructured, semi-structured, multi-structured. You feed anything, it will take and process it. That's the reason it is named as a PIG. Similarly, Hive. Hive is the database, similar to MySQL, DB2. HBase, column-oriented database. Cassandra, clustering database. MongoDB, it's also a clustering database. These are all different databases, right? In 2006, we used to have only core Hadoop. Core Hadoop means only HDFS and MapReduce. Later on, they have added multiple components like HBase, Zookeeper, 2009, some more components, 10 some more components. Now we have a complete full-fledged Hadoop with all the components. How do I understand when I say Hadoop, what are the internal components of Hadoop? There are mainly two components. One is storage, another is computation. You may ask one doubt here. Any computer has storage and computation, but how does it different? It's a distributed storage, distributed computation. Whenever we say Hadoop, Hadoop components are two: distributed storage and computation. What is distributed file system? Multiple computers put together. It's called a network, where computer is called as a node. When you load any file here in this network, that file data will be distributed to multiple nodes. File data will never be stored in one machine. Will be distributed across machines. Distributed data storage, right? You can also use single machine for distribution. You can have a partitions in one machine. So you can use multiple machines, single machine. It's called distributed file system. What is a cluster? Cluster contains computing engines. These are called nodes. But what for these nodes? We know client server. Look at this one. These are all hard disks. When you load data to the cluster, the data will be stored here in these machines. When you run a program will run here. Data will be stored here, programs will run here. These are the actual machines. These are the slaves. These are the workers. These fellows will do your actual work. This is where the distribution happens. Storage or computation. This is where you collect your results. These are called slaves. But who will monitor all these slaves? Who will distribute the data? Who will distribute computations? Who will monitor computations? Who will collect all these results? We should have information about all these machines. How many machines are there? Each machine holding how much amount of data. For this we have a master. Master node, name node. When this fails, we have a backup, secondary name node, secondary master. All put together, we call it a cluster. When I say cluster, there are three types of nodes. I introduce here data node, name node, secondary name node. This is the technology is being used. We don't say client, we don't say server, we don't say thin client. All that is gone. Name node, data node, secondary name node. Name node will contain a data of data what you store in data nodes. That we call it as a metadata. Some of you already know metadata. Data about data. What files you stored here, what directories you created here, how many machines are sharing your data, how many programs are running here, how much time each machine taken, what are the permissions there. Every damn information about this data will be there in master data as well as secondary data, secondary master. All these things put together is called cluster. Whenever you want to work with Hadoop, you need to configure this cluster in your machines. The first thing you are going to learn in Hadoop, how to configure name node, how to configure data node, how to configure secondary name node. Then you are done with the configuration of cluster. When you start running cluster, you should see all these daemons running. I am introducing another word, daemon. Daemon is nothing but engine, which can store something, process something. I should see all daemons running successfully, then you can say my cluster is running successfully in my machine. Now that machine is ready for data distribution, computation distribution, parallel processing. I can get advantages of all big data technologies. Clear? That's it. I'm done. Any questions? When you learn data science, big data analytics, minimum 60 to 70% hike in your salary without any negotiations. On top, it all depends on your negotiation skills. There are many cases, 100% hike, 150% hike also. I'm not exaggerating, it is true. 100% factor. You have been reading news, you have been watching videos, right? You go through it. Even today newspaper also, as I told you, 20 lakhs job opportunities and the salaries are very, very high. Trump is saying 130, okay, right? So here 200K is possible with data science. You go and show to him. Definitely they should process it. Per hour 200 to 250 day. Kranti, what do you say?
Maybe.
Maybe. Yeah, you go through the job sites, you do some kind of salary survey. Go to Indeed and do survey.
Yeah.
They will come to know. Maybe you can talk to some clients or consultants who is providing job opportunities in data science. You will come to know.
Sure.
Yeah, please. Yes. Different. Very good. Hadoop is a framework. Spark is also framework. Here for online people question is, what's your name? Narshima asked one question that you are saying Hadoop is a framework, Spark is a framework. Why should I learn Hadoop? Why should I learn Spark? Why can't I go with only Hadoop? Why can't I go with Spark? Right? What are the major differences? The difference is Hadoop stores data, runs programs in hard disk. Spark stores data, run programs in RAM. That's a big difference. When you are running in RAM, processing is faster. It's a temporary memory. Hadoop has a permanent storage. Spark does not have permanent storage. I told you Spark is an analytical tool. That's only for analysis. If you want to store data permanently, you get Hadoop also in cluster. On top of it, Spark. There you are going to integrate Spark with Hadoop. Here Hadoop capability is HDFS. Power is HDFS. HDFS, Hadoop Distributed File System, it is not normal file system, it is a highly intelligent file system. When we discuss architecture of HDFS, you will come to know. That intelligence we are going to use for Spark. Did you understand? This is one of the fundamental difference between Hadoop and Spark, but there are many. Another difference is I told you iterative algorithms in machine learning. Spark is more suitable for iterative algorithms. Hadoop is less suitable for iterative algorithms. Almost it is failed. Yeah, something you are trying to ask, Mr. Correct. 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 Yes. Yes. You can process independently, you can process together. Yeah, both are possible. Here not only Hadoop, you will be integrated with many other components like HBase, Cassandra, HBase, Hive, Elasticsearch. There are many. You can integrate with Kafka for different reasons. As a data scientist, you got to be involved in multiple tools and techniques. You are not going to be fixed for one tool or one technique. That will come automatically as you start working. You don't need to worry much about it. So nowadays you got to be multi-skill, or you should have multiple skills. You cannot carry on with one skill, saying that I know only XYZ ABC always. To increase your salary, to win in your appraisals. Always manager win in our appraisals, right? We don't win. Very rare. But if you are in big data, you will win always, I am telling you, at least for next 5 to 10 years. You should be able to see your future now. Okay? So as you work with the Spark, you will be able to guess what is going to be happening in the market. You can predict about your future. There is a possibility. There are many people who got jobs, local to abroad also. Japan recently one fellow got per month 3 lakhs. Company name is Indo Sakura, Japan based company. Indo Sakura is the company. In US also, I think starting with $200 per hour. Based on your skill set, you can go up to 300 based on your location, based on your negotiation skills. So this is all about data science and big data analytics, right? So new batches will start from Monday onwards 7:15 a.m. 7:15 a.m. So then weekend batches Saturday, Sunday, 3 o'clock, 3 p.m. 4 hours, 4 hours. Whatever we cover Monday to Friday, we cover on Saturday, Sunday. The program is designed in such a way that if you miss on working days, you can attend on weekdays. 7:15 a.m. 7:15 a.m. Okay? Don't waste time. Even if you don't join now, you will be forced to join after 6 months or after 1 year. I am telling you. You will be forced. You will be thrown from there to here. It has become a very big magnet. Because every company is talking about it. Every individual is talking about it. Especially a testing and mainframe background, even Java background, many people are coming and doing this course. In my previous batches, even morning and even back, there are many people from Tech Mahindra, Wipro, TCS, IBM, almost all companies and different varieties of experience. Don't think that you are 15 years, 16 years, doesn't matter. 0 to 25 years, everybody has a place here. It all depends on how you sell yourself. It's all learning. But you got to be ready for reading. A lot of reading will be there, a lot of practicing will be there. All my classes go with hands-on. You need to carry your laptop, sit here, do with me. Soon after the class, whatever I am, you will be the same, particular to that class. So whatever I teach here, you will learn and go, that's it. There won't be any ambiguity, zero. Clear all your doubts, particular to that topic, you do hands-on, close that session and go. Next day again, come with the laptop and do. Less theory, more practicals and more reading. So I will be giving you material, some books you have to read. Once you decide to join this course, this should become a high priority. All other things should become a second priority. Then only you take up this course, otherwise don't join. Waste of your time. You should not concentrate on other activities. You minimize that. I mean, prioritize your activities. But trust me, just spend 3 months time, 3 months to 4 months time, you are going to rock. I can guarantee you on that. I can bet on that. So I will design your resume based on your profile, based on your experience, based on your present skill set. I will be giving you individual guidance. After the completion of course or just before completion of course, I will sit with every individual to make sure you get a perfect resume. You will be completely transformed to data scientist in big data. That is guaranteed. What else is required? Once you are transformed, nothing. Transformation should happen. From mainframes to big data scientist, from QA to data scientist, from Oracle developer to data scientist, from mathematician to data scientist, from administrator to data scientist, from Java programmer to data scientist. That transformation has to happen. The transformation will happen when you practice, when you listen, when you read. Doesn't happen just like that. You got to be in that environment practically. It should be part of your body. That's all. DNA. You should love it. You should have a burning desire. That's it. Very simple. If you have that, you can get it whatever you want. You decide, write in your notebook, I want this salary, this company. Previously, 10 years before, we used to talk about only Infosys, TCS, Satyam, all these companies, right? The big companies. Now, there are many medium-sized companies, even small-sized companies offering excellent salaries. Pay masters paying more than the companies, the big companies, right? 1,000 people company, 2,000 people company, 3,000 people company. You will be getting multiple offers in your hand, right? I think I will close here. I assume there are no more doubts. If you still have doubts, I'll just take 5 minutes time to answer your queries and doubts. The online.
Hello, Srinivas.
Yes. Gandhi, tell me.
Yeah, hi. So basically, I
Speak
just
loudly,
wanted
Gandhi.
to, yeah, sure.
Yeah.
Yeah. So I just wanted to make sure, like, so in this class, we will be covering, I mean, in this course, it would be like data science and big data analytics. So that would be with Hadoop, Spark, Scala, and little bit of Python
Machine
and
learning, introduction to Python and R.
introduction to Python and R and
Yeah.
numeric. So these are
Machine learning, yes, machine learning.
okay. So these are the things which are going to be covered in this course.
Yes, yes.
Okay. And okay. Are there any other, I don't know if this is the right question to ask. So are there any other courses which cover the other things like MongoDB, HBase, Hive? I mean,
HBase Hive are included in Hadoop itself. Hadoop components, I'm just saying Hadoop, it contains multiple systems like Hive, Pig, MapReduce, HBase,
okay.
even Cassandra. Those are there. I think our people will forward curriculum to you. Just go
Okay.
through it.
Okay.
Whatever you asked, everything is there.
Okay, that should be fine then.
So I did a lot of R&D. I've gone through almost all the books and all the companies' projects and spoke to many individuals, experts, and prepared a curriculum. That curriculum suits to all companies' requirements. You can crack any interview. You can do your job without any problems. There won't be any major roadblocks when you follow that my curriculum. Okay?
Okay. Okay,
So I
sure.
have not left anything, so which will never stop your solving your problems.
Okay.
Is that answered, Kranti?
Yes, yes, yes. Thank you.
Okay, okay. Any questions? Online, any questions? Suresh, Vishwanath? Okay, if no questions, yeah. Suresh, tell me.
Uh, no questions, Srinivas. Sir.
No questions, great. Okay, Vishwanath?
Nothing from me, Srini. It was good.
Okay,
We got a very
except
right
for our online people, except shake hands, everything can happen here. Online people, can you hear me?
Yes, sir.
Yeah.
Except shake hands, everything can happen here. Okay, did you understand? Whatever, whoever people sitting here, people sitting outside of this class are same. You don't find any difference. The only thing is I can give my shake hands here. I cannot do with you. That's only the difference. The programming, explanation, practice, installations, configuration, everything is same. The same class will run. Only thing is you should not sleep while in front of the system, while sitting in front of the system. Generally, people get sleep while sitting on the system, early in the morning, 7:50 a.m. So when you have burning desire, you don't get sleep. Okay? Thank you.
Okay.
Thank you very much. I think I exit from online.
Yeah.
Okay. Thank you.
Yes, sir. Thanks for the nice session, sir.
Oh, great. Okay.
Thank you.
Okay.
Srini. Thanks. Bye. Yeah. Bye all.
Yeah. Configuration. Yeah. So 8 GB RAM, 1 terabyte hard disk is ideal. It will simplify your problems. Otherwise, while doing programming, your system is slow, you get irritated. So better to have high configuration. 8 GB RAM, 1 terabyte hard disk. OS is Ubuntu. If you have Windows, we have another virtual machine, so you know virtual machine, right? You can do that, but that is again slow. So otherwise, you will make a partition.
So better we are suggesting is that instruction, anyway you follow the operating system Windows, right? Parallel going to go for the Ubuntu. So that will start getting can install all the
Yeah, right. Once you do partition, we will take care of everything in the class itself, right? Ubuntu partition.
We'll take care of all.
Partition also can be done here. 3 months. It may go to 4 months. It may go to 4 months, but it should go 3 months. It may go to 4 months. You have to dedicate, that's it. There is no other goal. Then only do the course, otherwise you will be wasting your money and time. The time is more valuable. 1 hour 15 minutes. 5 days.
Yeah, the time starts is actually from starting tomorrow. Morning is 7:15 to morning 7:15 a.m. to 8:30 a.m. That is weekdays. Then weekdays also evening 5 to 6:30, 7:30 to 8:30. Same, the online and the class. These times start. And fourth is weekends, Saturday, Sunday, weekends.
Okay, so I think so that we are going to start from 7:15 with that. Okay, so from 7:15 to like 1 hour 15 minutes max is going to be started. I mean, already started at 8:30. Already from the well. If you are looking at the weekend also, we are starting from the 3 to 6 p.m. Then morning 9 a.m. to 12. If you have any doubt about the course, how many course duration and about the fees, then come with the that's another clear plan.
Evening weekend. Weekdays. Evening. Evening. Yeah. From 10 to 6:31. 6:30 to 7:30. More people coming, so 5 people are there. Now, average is 6:30 to 7:30. So some people are coming to 5 because many people will come. Yeah. They also want to take the feedback. Right? The course wise, content wise, yeah. So, the all the invitation. What are the this 2 hours? So that we can add those. Right? Because that is transcript. Other than you right? Next